Now we're going to talk about the surface area and volume of pyramids. So we need to start with some vocab and some formulas like we have on the others. So a pyramid is a polyhedron, which means that it's made up of all polygons. So the base is a polygon, and the lateral faces are triangles with a common vertex. So they all meet up here at a common vertex. The altitude or height of the pyramid is the perpendicular distance between the base and the vertex. So if this is a regular polygon down at the bottom, it will meet in the center of that vertex. So that's going to be our height or the altitude. It can go by either name. And we're going to call this H. So this goes down into the middle of the solid, and it is perpendicular to that base. The irregular pyramid is a pyramid that has a regular polygon for a base. So all the side lengths of this hexagon that we have here would be equal. So whenever we're talking about slant height, like we've mentioned it in our prisms, but we didn't really use it. And in pyramids, we have to use it. So the slant height of a prism is the height where it goes from that vertex and it goes down the face of the shape and then is perpendicular to that edge at the bottom. So it's going down through on the face and then hitting perpendicular at the bottom. So the slant height of a regular pyramid is the altitude of any lateral face. And for the slant height, we use the variable L. So notice that this shows up in our surface area formula, that variable L for the slant height. So there are a couple different ways that we might have to find the slant height if it's not given to us. So if we're working with a polyhedron with a regular base and we need to find the slant height, notice that they're perpendicular. So there's a few different ways that we can use this. So one way is, both the ways are going to use Pythagorean theorem, but it depends on what all you're given. So if you are given the height and the slant height L, another way that you can find one of those, like if you don't have anything else, and this is something that we'll need to find the area of the base as well, is this apothem length. So let me use a different color here. All right, so from that center out to the middle point, the midpoint where that slant height is coming down, that's going to form a right triangle. So this would be the apothem. So one Pythagorean theorem that I can use if I need to find the height, the altitude, or the slant height is with this. So that would be a squared plus h squared, because those form the legs of a right triangle. And that would be equal to the slant height squared. So that's one Pythagorean theorem that creates a right triangle. So another way that we could find our slant height, if we weren't given the altitude of the triangle, maybe we were given the edge length. So this lateral edge, let's call it E. It does not show up in our surface area or our volume formula, but sometimes it is given to us. So if we had the edge, we could use the slant height here. So since this is a regular polyhedron, the slant height is going to be the same on any of the faces, and it's still perpendicular. And then since it's hitting in the middle, that would use half of the side length. So they all have the same side length. This would just be half of it. So if I was doing Pythagorean theorem with a side length and an edge length, that would be 1/2 s, so half the side length squared, plus the slant height is a leg in this right triangle. So leg squared. And that would equal the edge. The edge would be the hypotenuse in that right triangle. So that would be equals edge squared. So we can use Pythagorean theorem to find a height or a slant height. If we did not have the other information, we would just need the length of the apothem, or we would need the edge length and the side length. All right, so our formulas for our surface area. So since we're dealing with a pyramid, it only has one base this time. We're going to take the base, and then since each of these lateral faces are triangles, to find the area of a triangle, you do 1/2 base times height. And in this triangle that's on the face, the slant height is the height of the triangle. So instead of doing each triangle individually and then adding them all together, we can just do the perimeter times that slant height and 1/2 of that. So this is kind of coming from the triangle area formula. So that's how we found our surface area. For the volume of a pyramid, the volume is going to be 1/3 the area of the base times the height. So this is going to be 1/3 of the volume of a prism that has the same base area and the same height. So I'm going to also attach a video that has like a visual representation of why that works. So we're going to use this example and we're going to identify, like find it or identify the height and the slant height. So in this, we have a square base where each side length is 2, and we have a perpendicular coming up from the center of the base up to this vertex where all of those lateral faces meet. This, since it goes up through the middle of the shape, this is the height of the pyramid. So I've got the height, but now I need to find the slant height. So the slant height is going to be going down a face. So if I go down the face, the lateral face, and I come perpendicular to that side, it's going to be at its midpoint. And to find this slant height, I'm going to need to use the apothem. So the apothem of a square is actually pretty easy to find, because since this is the middle, it's going to be halfway across. And so if all the way across is 2, then halfway across would be 1. So for this one, I am using that first Pythagorean theorem that we wrote down. So we're going to do apothem squared plus height squared equals slant height squared. So the apothem, since this was a square, and this only works for squares, we'll look at how to do it on a hexagon a little later, but I'm going to plug these in. So my apothem here is half of the side length, which would be 1. So that'll be 1 squared plus the height of the entire pyramid, which would be 8 squared. And what I'm trying to find is the slant height. So I need to solve the Pythagorean theorem to find the slant height. So 1 squared is 1, and 8 squared is 64. So I need to add those together. 1 plus 64 gives me 65. So the slant height squared is 65. So to get rid of this square, I use the square root. So the slant height is going to be the square root of 65. So 65 isn't a perfect square. That's an irrational number. So the exact answer is the square root of 65, and we can use a calculator to estimate it. So the square root of 65 is approximately 8.06. So another way we could do this is that the slant height is approximately 8.06. So that is this length right here along the face. This is the slant height, and that is 8.06. So the reason we use the variable L is because that's the height of the lateral face. All right, so now that we've identified and we found those measurements, we're ready to move on to finding surface area and volume. So we've got our formulas up here. So we have base, we have perimeter, slant height, and height. Those are the things that we might need to find each of these. So I just need to identify the pieces that I know. So the 15 here, since it goes down through to the middle of that base, this is the height of the entire pyramid. 7 is a side length. So things that I don't know the slant height. And so to find the slant height using these, if I go back to those Pythagorean theorems, I know that I need the slant height and I was given the height. So for slant height and height, that's going to be this first one. So a squared plus h squared equals l squared. So to use this, I need to find the apothem. So in a square, this was the only one where this special trick works. So to find the apothem, what I do is, because it's going to be exactly half of this side length, because it's going to be parallel, I'm going to take half of 7. So 7 divided by 2 is 3.5. So that's what I'm going to use for the apothem of this square. All right, so I have 3.5 squared plus the height, which was 15 squared, is going to be the slant height squared. So as I go through, I do 3.5 squared, which is 12.25. And then 15 squared is 225. And that's going to equal the lateral height squared. All right, so I need to add those together now. 12.25 plus 225 is 237.25. And that's going to be equal to the slant height squared. So I need to take the square root of both sides. So I do the square root of 237.25. And I'm going to go in and round this. And so up here it says to round to 2 decimal places. So I'm going to take this. I'm going to say the slant height is 15.40. All right, so slant height was one of the things that I need. So now I know what the value of L is. The next thing I need is the area of the base. So I've got one thing that I need. Next, I need to find the area of the base. So since the base here is a square, I can do length times width, or since it's the same, the area of the base is going to be side squared. So I'm going to do 7 squared, which is going to give me 49. So the base, let me put that down below there. The base is going to equal 49. That's another thing that I need for that surface area formula. Last thing I need is the perimeter. So a square has 4 sides. So for the perimeter, I'm going to do 4 times the side length. And 4 times 7 is 28. So my perimeter is 28. So now I have all of the things that I need to find my surface area. So I'm going to plug this into my formula. So the surface area equals the base plus 1/2 the perimeter times the slant height. So if I plug in these numbers, I know the area of the base was 49. The perimeter was 28. And the slant height was 15.40. Oops. All right, so now I'm ready to multiply and add that. So I'm going to type that directly into the calculator very carefully. So the area of the base was 49 plus 1/2 times 28 times 15.40. So I get a surface area of 264.60 or 0.6. All right, so area is measured in square units. So this will be centimeters squared or square centimeters. So my surface area is 264.6 square centimeters. I also have everything I need for my volume. I have my base area and I have my height. So to find the volume, I'm going to plug into this formula. So that'll be 1/3 times the area of the base, which was 49, times the height, which was 15. So I'm going to multiply that together. 1/3 times 49 times 15 is 245. So the volume is 245. Volume is three-dimensional, so that is cubic centimeters. So that was for a square pyramid. The base was a square. So our work changes a little bit each time because the shape that we're dealing with changes a little bit. So our next one we're going to look at is a equilateral triangle as the base, and then it is a pyramid from there. So each of these side lengths are going to be congruent. So looking at what I have, a side length is 7. Now this height that we're given goes down along the face. So this is the slant height. The part that I don't have is the regular height. So going from the middle up to the top, I don't have that number. That would be the height. So looking at my surface area formula for this one, I have my slant height, and I need to find my area of my base, and I need to find my perimeter. So since this base is an equilateral triangle, the area formula for an equilateral triangle is the square root of 3 over 4 side squared. So I do have the side lengths. I'm just going to plug that in. So square root of 3 over 4 times 7 squared. So let's go in and plug this in and estimate what our base is going to be. So square root of 3 over 4 times 7 squared. And I'm going to go in and round it to 2 decimal places. So this will be 21.22. So once I'm ready, I have my base area now. So check. Now I need the perimeter. So for a equilateral triangle, there are 3 sides, and each side length is 7 meters long. So the perimeter of this shape is going to be 3 times 7, which is 21. So now I'm ready with my perimeter. So at this point, I have everything I need to find the surface area. So the surface area equals the area of the base plus 1/2 times the perimeter times the slant height. So for my surface area, I'm going to go in and plug in my base area. And then I'm going to do plus 1/2, and I'm going to plug in the perimeter, which was 21, and my slant height. So the slant height was in the original picture, and that was 8. So to find my surface area, I'm going to turn to my calculator. So 21.22 plus 1/2 times 21 times 8. All right, so altogether, this gives me a surface area of 105.22. I want to put some units on it, so area is in square units, so that will be square meters. All right, now I'm ready to try to find my volume. So the formula for volume is 1/3 the area of the base times the height. So I've got the base area, but I do not have the height. So to find the height, I need to use one of my Pythagorean theorem formulas. So I have the slant height, but I need the height. So the first one is the only one that has h in it. So I'm going to use that same one. A squared plus h squared equals L squared. So in this, I'm going to need my apothem. So if I'm finding my apothem, if we think back to our area unit, I have to think about this right triangle that's being made here at the bottom to find my apothem. So if I focus in on this little right triangle, so I'm going to draw my base. So the whole base is a equilateral triangle. The apothem is going to go from the center down to that side. And it's going to cut that side exactly in half. So half of 7 is 3.5. Now I'm going to think about this little right triangle that's drawn as a radius. So to find the measure of this central angle, I'm going to take the entire central angle, which would be 360 degrees divided by 3. So if I do 360 divided by 3, I get 120. I want to focus in and I only want to use half of that though. So half of 120 is 60. So that means that this angle up here is 60 degrees. So this one down here, this little angle right here, would be 30 degrees. What I'm trying to find is the apothem. So I'm going to use a trig ratio here to figure out the value of the apothem A. So based on the 30-degree angle, if I choose an angle, and if I choose this 30-degree angle, the A is opposite and the 3.5 is adjacent. So that tells me opposite and adjacent, I need to use tangent. That's the SOHCAHTOA. So tangent of 30 degrees is going to equal the opposite, A, over the adjacent, 3.5. So to get A by itself, I need to multiply both sides by 3.5. I'm going to come back over here to my calculator. When you're using trig functions, it's really important to check your mode. Make sure you're not in radians. Make sure you are in degrees. So I'm going to do 3.5 times the tangent of 30 degrees. And that's going to tell me that the apothem is about 2.02. So now that I have that apothem, I can use this Pythagorean theorem up here. So in the Pythagorean theorem, I'm going to plug in 2.02 as A. So see, it's a lot easier when we're working with squares, but it's possible using our knowledge of area of polygons from our previous unit. I'm going to erase this so I can get myself a little more room. All right, so the height is what I'm trying to find. And I was given the slant height was 8. All right, so I'm trying to find the height of this triangle, or the height of this pyramid. All right, so I need to work through and find the height. So I have 2.02 squared. It's going to give me 4.0804. And then 8 squared is 64. So I need to subtract 4.08. I'm going to go in and shorten it. So 64 minus 4.08 is 59.92. That's going to be h squared. I need a little more room. Sorry, triangle. And then I'm going to take the square root of that. So the square root of 59.92 is 7.74. All right, so we're going to use that in our formula now. Now I have enough to do my volume. So the volume is going to equal 1/3 times the area of the base, which we found earlier to be 21.22, times our height, which we just found was 7.74. So now we're going to multiply this together. 1/3 times 21.22 times 7.74. So the volume of this triangular pyramid is going to be 54.75, and then volume is measured in cubic units, so this will be cubic meters. All right, we have one more pyramid to find, and this one is going to be a hexagon base. So let's look at what we're given. The 6 here is a side length. The 12 that we're given is an edge. So for this one, we don't have our height or our slant height because this is an edge length. So if I need to find my slant height and my height, I need to go back to that Pythagorean theorem and go on and make this useful from the beginning. So from my Pythagorean theorem, when I have an edge length, I need to use the second one. So that's going to be half the side squared plus the lateral height squared equals the edge. So I'm going to go and copy that down. So 1/2 of a side squared plus the lateral height squared equals the edge squared. So let's just go back, make sure I copied it down correctly. All right. I'm just going to grab this and we'll move it down here. All right, so to start plugging in, first I need half the side length. So if the side length is 6, half of that is 3. So I'm going to do 3 squared plus slant height squared is going to equal the edge squared, and the edge was 12. So as I go down through here, 3 squared is 9. So 9 plus L squared, 12 squared is 144. So now I have 9 plus L squared equals 144. I'm going to subtract 9 from both sides. So I do 144 minus 9, and I get 135. So to find that slant height, I'm going to take the square root of both sides. So the square root of 135 is about 11.62. So we're still rounding to 2 decimal places. So when I need the lateral height or the slant height, it's going to be 11.62. Now, so to take a look back at our surface area formula, just so we can keep track of the pieces we have and the pieces we need. So the base plus 1/2 perimeter and the slant height. So now I have the slant height. I need the area of the base and I need the perimeter. So for the area of the base, since this is a hexagon, that's going to use our polygon area formula. So the area of this base is going to equal 1/2 apothem times perimeter. So in this area formula for my base, I need the perimeter there too. So let's go in and find the perimeter of this shape. So the perimeter is going to equal the number of sides, and there were 6 sides on a hexagon, times the side length, which was 6. So the perimeter of this shape is 36. So the other thing I need for this area of the base formula is the apothem. So we're going to use that same process that we went through here to find the apothem of this hexagon that's on the bottom of this. So I start by locating the center point. Then I'm going to take this center point out to the edge. So this is going to be perpendicular. And what that does is it cuts this edge in half. So I'm looking at half of that. So this little side length, if the whole edge was 6, this will be 3. So I made a little right triangle here. And now I need to find the angle measure. So the central angle, I'm going to take the whole circle, which is 360, and I'm going to divide that by the number of sides. So that's divided by 6. So this entire central angle would be 60. I'm only looking at half of that, so this is 30 degrees. So with this 30-degree angle that I have up here at the top, I can use a trig function to find the apothem again. So I can use my 30, 60, 90 triangle and follow that pattern, or I can use the trig function. So if I use a trig function, looking at this triangle, the 3 is going to be opposite of that 30-degree angle, and the A is going to be adjacent. So I'm going to use tangent again. So I'm going to say tangent of 30 degrees is equal to opposite over adjacent. All right, so here my variable is on the bottom. So remember that property of cross products, and that property of cross products says that cross products can switch places. So I'm going to flip those around, and this is going to be A equals 3 divided by tangent of 30. So I switch those cross products, and that gets the A by itself. So to find the apothem, I'm going to plug this in and round it. So this will be 3 over the tangent of 30 degrees, which is going to be about 5.20 when I round it. So the apothem here is about 5.2. So now that I have that, I am going to plug that into my formula. So the area of the base is going to be 1/2 of the apothem, which is 5.2, times the perimeter, which is 36, and plug that into my calculator. 1/2 times 5.2 times 36 is 93.6. So the area of the base is 93.6. So that's ready to plug into my formula as well. All right, so taking these numbers that we found and plugging those in, the area of the base was 93.6. I need to add that on to the area of each of those little triangles. So I'm going to do 1/2 times the perimeter, which was 36. I already found that to find the area. And then the slant height, which was 11.62. Now I'm going to plug this into my calculator. So 93.6 plus 1/2 times 36 times 11.62. And that gives me my surface area of 302.76. And that's going to be in square units. So that'll be square centimeters. All right, what we have left to find is the volume. And so for the volume, we're going to hit another problem, because I have my base area, but I still don't have the height. So I still need to find this height, h. So that's going to require another Pythagorean theorem. So now, if I want to find the height h, I have to use the first one. So a squared plus h squared equals L squared. Luckily, we already have the apothem on this one. So a squared plus h squared equals L squared. And then I'm going to plug in what I know. So I already found the apothem. So that's 5.2 squared plus h squared is going to equal L squared. And L was 11.62. All right, I'm going to work through this. So 5.2 squared is 27.04 plus h squared equals, I need to find 11.62 squared, which is 135.02 if I round it to 2 decimal places. Now I'm ready to solve, so I'm going to subtract 27.04 from both sides. So 135.02 minus 27.04 gives me 107.98 for h squared. And I'm going to take the square root of that. So the square root of 107.98 is 10.39. So now that I have my height, I'm ready to find the volume. So let's plug in what we know. So 1/3 the area of the base, which was 93.6, times the height, which was 10.39. Plug this into my calculator. So 1/3 times 93.6 times 10.39 gives me the total volume of 324.17 when I round it, and that's going to be in cubic units. So this is centimeters cubed. So once we get out of our square, it takes a little bit more work to find that surface area and volume.